Let's do a two-sample t-test in Minitab. Let's investigate the question, do cars with cruise control cost more than cars without cruise control? We'll do this using a two-sample t-test comparing the mean price of all cars with cruise control and the mean price of all cars without cruise control. Here we have a data set including the prices of used cars and whether or not those cars have cruise control. But you'll notice that the cars with and without cruise control are all mixed together in the same column. So the first thing we need to do is figure out how many cars with and without cruise control we have. We can do that by going to Stat, Tables, Tally Individual Variables. Then we want to choose the variable we want to count, which in this case is C10, cruise. And we'll display counts of the numbers of observations with each possible value of cruise. Here we see that we have 8 cars without cruise control and 12 cars with cruise control, for a total sample size of 20. Those are fairly small sample sizes, so in order to use a two-sample t-test, we'll need to check the other assumption, that of the individual observations being normally distributed. We can do that by going to Graph and choosing Probability Plot to get a normal probability plot of the prices. Choose Single and OK. Then choose the variables we want to make a graph of. In this case, that's price. We want multiple graphs, one for cruise equal to no and one for cruise equal to yes. So click on Multiple Graphs, Show Graph Variables on Separate Graphs, and then click on the By Variables tab. This lets us tell Minitab which variable to split up by to make our different graphs. You can choose either separate panels or separate graphs. I'll use separate graphs to make it a little easier to see. So click in this second box and then select the variable we want to use to split up our graphs, which is cruise. Then click OK and OK again. Here we have normal probability plots of price with cruise equal to no and cruise equal to yes. Here you can see that the points all fall between the curved lines. Although for the cruise equal to no plot, there is one point that's just on the curved line. This means it might be a good idea to go out and gather a larger sample before we can fully trust the results of our two-sample t-test. But for now, this is all the data we have, so let's go ahead and try the two-sample t-test. We can do that by choosing the Stat menu and choosing Basic Statistics, Two-Sample T. Both samples are in the same column, so click in the Samples box and choose the variable that we want to take the mean of. That's going to be our price. And click Select to enter it into the box next to the samples. Then click in the box for sample IDs and choose the variable we want to use to split up our two separate samples. In this case, that's cruise. Click on Options and choose the hypothesized difference and alternative hypothesis that we're interested in. In our case, we're interested in the null hypothesis that mu cruise equals mu sub no. That means that mu cruise minus mu sub no would equal 0. So our hypothesized difference is 0. The alternative hypothesis is that cars with cruise control cost more. So we'll choose difference greater than hypothesized difference. We're not doing a confidence interval here, so you can leave the confidence interval at 95. leave the Assume Equal Variances box unchecked. Then click OK and OK again. Here you can see our results in the Session box. Looking at our results, we see that we got a very large p-value, close to 1. That's a good indication that we might want to double-check our alternative hypothesis. Up here, you can see that Minitab is calculating the difference as mu no minus mu yes. That means we're taking the cars without cruise control and subtracting the cars with cruise control. So our alternative hypothesis should actually have been less than rather than greater than. So we can redo our test, again going to Stat, Basic Statistics, to sample t, but this time we'll change our alternative hypothesis to be less than. In this case, we get a p-value of 0.002. This is less than 0.05, so we reject the null hypothesis and claim there is enough evidence to claim that the mean price of all cars with cruise control is greater than the mean price of all cars without cruise control.